the aircraft themselves remains a huge challenge. Every day, planes enter the most hostile environment imaginable. Flying higher than Mount Everest, battered by winds of hundreds of miles an hour, we just expect them to function perfectly, flight after flight. But as they rack up air miles, there's one extreme hazard all aircraft will invariably run into. Lightning. By far the most dangerous, powerful force of nature your plane is ever likely to encounter. Down on the ground, getting struck by lightning's a rare event. Not so up in the air. In fact, every plane gets struck by lightning once a year on average. That means across a typical jet's lifetime, it'll get zapped an astonishing 25 times. So why aren't passengers regularly getting electrocuted in flight? It's thanks in part to the kind of research they do here in Darmstadt, Germany.
Alles klar, wir können loslegen.
At Darmstadt University's High Voltage Lab, Professor Volker Hinrichsen and his team study lightning protection. A car offers you much the same protection as a plane. They're both metal boxes with people inside. The lab's lightning generator is designed to build up enough electrical charge to fire a 2 million volt bolt of electricity. That's a small but very realistic lightning strike. More than enough electricity to turn Volker into a smoking heap.
So I have just to wait. They are charging the generator now, and very suddenly it will be discharged.
5, 4, 3, 2, 1, Schuss.
Wow, that was... So we have now the discharge, and you see, nothing happened to me. It's absolutely safe in the car.
Schuss.
You see, I'm still alive.
A single bolt is too quick to see in detail, but the lab can generate a slower electric pulse to help show what happens when lightning hits a metal enclosure. This car may be on the ground, but electricity flows through a plane in the air in a very similar way.
It's a quite simple principle in electrical engineering. So that is what we name a Faraday cage. That means the strike terminates on the car, it discharges on the car, and the charge flows over the metallic surface of the car, bypasses me, doesn't flow through my body, and that is why I'm surviving that.
It's thanks to the Faraday effect that we're kept safe when a metal plane gets struck by lightning. That's all very well for passenger planes still made of metal, but it poses a problem for the new breed of composite aircraft. Composite doesn't disperse electricity in the same way as metal, so without protection, these planes and their passengers would be in real danger. Here, in a nondescript industrial zone in South Wales, a research team is studying how composite planes are affected by lightning. To help illustrate what happens when a non-metallic plane component fails to disperse a lightning strike, they've offered to demonstrate on this rather charming non-metallic garden ornament. The only way to capture the moment of impact is by using an ultra-high-speed camera, insulated in a blast-proof box. The gnome didn't fare too well. It's the job of Professor Manu Haddad to make sure the destructive power of lightning never has this impact on a plane. And non-metallic composite parts gave him a real headache.
The reason why we do this research is that you need to make sure that any material that you use in aircraft is actually safe when it's hit by lightning. If there was no lightning protection design, you would have a very disastrous effect due to a lightning strike.
So what happens to unprotected composite when it's zapped by an artificial lightning bolt?
3, 2, 1.
When this ordinary carbon composite is hit by lightning, strips of carbon fiber are blasted off the surface. You really wouldn't want that to happen to your aircraft's hull at 10,000 feet. It was a huge challenge to find a way of protecting the new generation of composite planes from this type of damage. After decades with no large jets lost to lightning strikes, nobody wanted to see this threat re-emerge. So engineers came up with a brilliantly simple plan.
Fortunately, we have a very good solution, and this is using a copper mesh, a very thin copper mesh that you would put on top of the carbon composite, and that will allow then the distribution of the current uniformly on the surface and avoid the damage that you see here. And this is the protected side, which has the mesh.
The delicate layer of copper webbing embedded on the other side of the plate should, in theory, protect a composite plane.
As you can see, there is very little damage on the surface of the panel this time. What the protection or the mesh that we put here did, it guaranteed that the current is actually distributed uniformly. As you can see, this is a very good demonstration on how lightning protection of carbon composites works.
So every new plane made with carbon composite now rolls off the assembly line with a fine protective copper mesh beneath the paintwork, an innovation keeping you, the passenger, safe from a 100 million volt lightning strike.
Without this, the consequences